Hi, welcome to Lesson 11, the Continental Jigsaw Puzzle. If you remember last time we talked about the Glarus thrust, this problematic feature in the Swiss Alps where you get young rocks underneath old rocks. And the only mechanism that makes sense for that to happen is for the old rocks to have been thrust a long distance and placed on top of the young rocks. But it really is problematic because that's a large-scale movement, and as of yet we have no mechanism to suggest that that could be possible. One theory was global shrinking. If you remember, we talked about Kelvin, and his method of dating the Earth was cooling of the Earth and figuring out the rate of cooling rocks and how much molten rock would have been on the Earth, and therefore how old the Earth might be. So similarly, global shrinking relies on global cooling and the contraction that would occur as a result of global cooling. So that contraction, that cooling, would cause a volume change on Earth, and the surface of the Earth would have to compensate by crinkling and thrusting over itself and mushing around to compensate for this change in space, the change in volume of the Earth as a result of cooling. Global shrinking could potentially explain these contractional, convergent features, these thrusts, where you would expect contraction and shrinking of the Earth. But there are also lots of features on Earth that indicate extension of the crust has happened. I'll go over a few of them. Glacial tillites in Africa can be found near the equator, which is very strange because a glacial tillite is the lithified version of glacial till. Glacial till is a glacial sediment, which is just a sort of poorly sorted jumble of silt and boulders and gravel and sand, all dropped out of a melting glacier. So you wouldn't expect to find glaciers in equatorial Africa. And so the placement of these rocks is a bit puzzling. How did they even get there in the first place? The inverse of that is in Antarctica, where you find coal beds, coal deposits that would have formed in tropical climates. And yet there they are in barren, cold Antarctica. So obviously things on Earth have changed since ancient times when these rocks were made. Another example is the placement and location of fossils across continents. A famous example is Glossopteris, a tree-like leafy plant. You can find that it links all sorts of continents. It goes from South America to Africa, into India, into Antarctica, into Australia. And it joins them as if they were all once linked together. Similarly, a freshwater reptile called Mesosaurus links South America and Africa. So it seems like all these continents were once joined together. And I mean, there's also just the fact that the fit of them looks like they should fit together. And all those little tidbits of evidence kind of point towards all the continents once being together and having since separated or extended across the crust, which is totally not what global shrinking would predict. So there's a problem in that these phenomena aren't explained by the model. Besides which, there's the idea of radioactivity that's come about in the early 1900s, and radioactivity provides a mechanism for the Earth to be much older than a global cooling would predict. Because now that we have the likes of uranium and thorium and potassium decaying inside the Earth, it can be heated almost perpetually as a result of the energy given off by these decay reactions. So even though global shrinking was out on Earth, it actually turns out it might not have been such a bad idea after all, because the Moon and Mercury all show signs of a contraction due to cooling and subsequent sort of crinkling of the surface without any other, I guess you'd say, tectonic action, but we'll get to that. Fossils, tillites, Antarctic coal, it all points towards the continents being joined at one time. And this led to the very, very unpopular idea that somehow the continents were joined and had since spread apart. But how could this be? And thus we come to the theory of continental drift, the famous idea proposed by Alfred Wegener in 1912. Others had suggested the idea before, but it was Wegener who sort of formalized it as a scientific concept. And he's the one famous for coming up with continental drift. Wegener's continental drift proposed that the continents were once fused together and had since sailed across the oceans to form in their current locations. He presented this to the German Geological Society, and of course they said, "Great, that's a nice idea. How did it happen? What is your mechanism?" And of course Wegener didn't have a mechanism. He didn't know how this was possible, but the evidence for continental drift seemed overwhelming. The evidence for a mechanism for continental drift was beyond underwhelming, and so he wasn't taken seriously. It of course didn't help that Wegener wasn't even a geologist. He was a meteorologist, known for his polar expeditions and work in that realm of science. So he wasn't even seen as a real expert at this. Until he could explain how these continents ended up across the globe, continental drift was sort of doomed. Simply put, more evidence was needed for continental drift to be taken seriously. And that would have to wait until there was serious political change. And it wasn't until the beginning of the Cold War that we would learn anything more about the strange fit of the continents and the mysterious links tying them together.